Good day everyone, my name is Ching. This is my FIP presentation video and my FIP title is Simulation Study of Gallium Nitride based Inverter for Electrical Vehicle Application using Matlab, and my supervisor is Dr. Anas. So let's start with the introduction of my project. When we talk about eco-friendly, the slogan that first come into our mind is the 3R slogan. The 3R, which is reuse, reduce and recycle. There is one technology that is able to fulfill the requirement of eco-friendly, which is the electrical vehicle. There are two types of electrical in this market, which is the hybrid electrical vehicle and the battery electrical vehicle. Both types of vehicle are able to achieve a zero emission of carbon dioxide gases and also greenhouse gases. There are one country in this world, which is the Norway, is the country with the highest rate of using EV, and this because due to the geography of the country, there are a lot of valley and also river in this country, so the government can easily build the hydro plant to generate the electricity. And furthermore, the government also encourage their citizens to buy the electrical vehicle by lowering the tax of the vehicle. The next thing is there's a lot of important power device inside an electrical vehicle. An inverter is one of the important power device in the electrical vehicle. And this inverter is in charge of conversion of the energy, which is it will in charge of convert the DC current generated by the battery to the AC current to drive the three-phase motor of the electrical vehicle. And this inverter has created a lot of problems such as the low efficiency of conversion of energy. So I have proposed use the wide bandgap semiconductor to overcome this problem. The wide bandgap semiconductor has the characteristics of high switching frequency and it supports high voltage operation, and lastly, it has a high electron mobility. Next is the problem statement of the project. Electrical vehicle requires a high-end technology to the human, and the researcher and the consumer also have their own problem to concern. The problem that the researcher concern is the thermal management of the device. If the device inside the electrical is too high, the performance of the electrical vehicle will be lower. And the next problem that researcher concern is the conversion of energy, which is the conversion of the energy in the battery pack to drive the motor. And the device to do the job is the inverter. So the inverter is sit between the battery pack and also the motor of the electrical vehicle. So the inverter needs to have very high efficiency in order to reduce the conversion of energy loss during the process. Next is the problem that consumer concern, which is the overall cost of the vehicle. But by using this gallium nitride as the base material to build an inverter, it able to lower about 10% of the overall cost when compared to the typical semiconductor, which is the silicon. Next is the objective to be achieved in this project. There will be two objectives to be achieved. The first objective is to analyze the performance of the gallium nitride based inverter for electrical vehicle. The second objective is to compare the performance of gallium nitride based and silicon carbide based inverter. After that is the scope of work in this project. The output waveform will be directly simulated by using Matlab Simulink. The performance such as power loss will be calculated by using Matlab code, and the data was obtained from the MOSFET datasheet. The target of the project is to compare the performance between gallium nitride based and silicon carbide based inverter. The parameter will be used to compare are the conduction loss, switching loss, inverter loss, and the switching frequencies. The next part is the methodology of this project. In this project, it will separate into three stages. The first stage is the exploration stage, which is will explore everything about electric vehicle, inverter, and gallium nitride semiconductor. The next stage is build and simulate. In this stage, I will test the circuit by using the gallium nitride MOSFET and also the silicon carbide MOSFET. Next, I will build and test the inverter circuit in Matlab Simulink. And lastly, I will calculate the power loss of the inverter according to the material. The last stage is the performance comparison, which is compare the performance of the inverter by using gallium nitride MOSFET and also silicon carbide MOSFET. Next is the software for simulation that used in this project. Of course, the project will be based on fully Matlab, and Matlab is a very famous software among researchers and also students. And the Simulink is one of the features inside the Matlab. And the simulation of Simulink is based on totally block diagram. And to further simulate the circuit of inverter in this project, an extension need to be installed to the Matlab, which is the SceneScape. And this SceneScape extension provides a library of simulating electronic device. So these two reference module is to obtain the output characteristic and transfer characteristic graph of the MOSFET. So at the left hand side is the output characteristics reference module, and the right hand side is the transfer characteristic reference module. Next is the result from this project. The first thing is the output characteristic graph. We can see that the left hand side is the output characteristic graph for gallium nitride MOSFET, and the right hand side is the output characteristic of silicon carbide MOSFET. We can see that the overall graph at about gate voltage 12, the drain current can achieve more than 200, while for silicon carbide MOSFET is for gate voltage 12 is only can achieve about 15 to 20 ampere. So we can see that the gallium nitride MOSFET have a potential to generate more drain current. And besides that, we further comparison based on the graph. At the VDS equals to 4 voltage and the gate voltage is 6, we can see that the difference between these two material of MOSFET is about 12.34 ampere. While at the same VDS and the gate voltage is equals to 8, the difference of these two MOSFET is about 49.369 ampere. Next is the transfer characteristic graph of these two MOSFETs. So we can see that at the left hand side, the transfer characteristics of gallium nitride and silicon carbide MOSFET, the slope of gallium nitride MOSFET is steeper than the silicon carbide MOSFET. At the left hand side is the transfer characteristic of gallium nitride and silicon carbide MOSFET. The blue color line is the gallium nitride, while the orange color line is the silicon carbide. And the blue color line shows it has a steeper slope than the orange line. And the graph at the right hand side is the threshold voltage of these two MOSFET. The threshold voltage for gallium nitride MOSFET is about 3.9 volt, while for silicon carbide is 2.8. It shows that the gallium nitride MOSFET has a higher threshold voltage compared to the silicon carbide MOSFET. It will result in better performance, especially when applying in the resonance. So this is the 3-phase 180-degree mood inverter model. In this model, they will be built up from 6 MOSFET, and each MOSFET can be adjusted according to the material that we require in this project. And each MOSFET has been connected to a gate pulse generator, has different phase in order to generate a 3-phase voltage. So here is the gate pulse for each MOSFET. All these MOSFET is designed in pair, and both of them will be opposite each other. Like for example, MOSFET 1 and MOSFET 4 is in pair, and MOSFET 3 and MOSFET 6 in pair, and lastly MOSFET 5 in pair with MOSFET 2. And the amplitude for each gate pulse will be 5 volt, and the frequency is 50 Hz. Next is the output waveform of the 3-phase voltage of this inverter. For both material, the output waveform of the 3-phase voltage will be the same, but however, the difference is the voltage drop of both material, and it's shown in the graph at the right hand side. The blue color line is the gallium nitride based inverter, and the orange line is a silicon carbide based inverter. and the input voltage of our inverter is 300 volt, and we can see that the output voltage drop of gallium nitride based inverter is 299, and the silicon carbide based inverter is 297. So it shows that the gallium nitride has a small voltage drop compared to the silicon carbide based inverter. Next is the conduction loss of both material. The conduction loss is calculated by using the formula RDS on time with square of I on. The conduction loss for gallium nitride MOSFET is 77 watt and silicon carbide is 100 watt. And by using gallium nitride MOSFET, the loss reduction is about 22%. Next is the switching loss. The switching loss is calculated by using the formula, the sum of turn on and off energy and time with the switching frequency. And this switching loss will be increased when the frequency is increased also. The gallium nitride MOSFET show a potential in controlling the switching loss of the inverter. Since when the switching frequency is increasing, the switching loss will be smaller than the silicon carbide MOSFET. And overall, by using gallium nitride MOSFET, the loss reduction of this switching loss is approximate 2 to 3%. Next, this is the graph of switching loss versus switching frequency. We can see that both of the relationship is directly proportional, and the blue line is represent the silicon carbide MOSFET, and the orange line is the gallium nitride MOSFET. Both of them will be increased according to the frequency. However, when the frequency is getting higher, both of the lines start to separate at each other, and this shows that the gallium nitride MOSFET has a higher potential in controlling the switching loss of the inverter. Next is the total inverter loss. The total inverter loss has been calculated by using the sum of switching loss and also the conduction loss. And inside our inverter, there will be 6 MOSFET used, so we have to times 6 in order to obtain our total inverter loss. So by using gallium nitride MOSFET to build an inverter, it's able to reduce the loss by 22%. And the loss reduction for each switching frequency are the same. And this is the graph of switching frequency versus total inverter loss. The blue line is represent the silicon carbide MOSFET inverter, and the orange line is the gallium nitride MOSFET inverter. You can see that between these two lines, there is a huge gap between it. So we can conclude that the gallium nitride MOSFET has a higher potential to control all the loss of the inverter. So in conclusion, the gallium nitride based inverter for electrical vehicle application has been proved by experimentally through the simulation software Matlab. And the gallium nitride based inverter shows a high potential in reducing conduction loss and the switching loss of an inverter. The total inverter loss of a gallium nitride based inverter able to reduce by approximate 22.73%. Next is the recommendation of this project. When in the process of obtaining the transfer and output characteristic graph of both MOSFET, the latest version of Matlab shows a problem, which is it will conclude everything that you have extract from the simulating scope into one folder in the workplace. And the name of the data declared by the Matlab itself is always changing variable. And this caused the problem of the output characteristic graph is unable to achieve when you set for different gate voltage. So my recommendation is using an older version of Matlab. My recommend version is 2018B version. Next is the temperature consideration. In order to increase the sustainability and also the accuracy of this project, in the future work, we can consider a range of testing temperature for the inverter in order to obtain an even more accurate result of the inverter. and also the performance of the inverter based on different temperature. The last recommendation is the testing load of the inverter. The Matlab simulating has a various functions, such as it have a built-in motor modules for us students to study about the working principle of the motor. So in the future work, I recommended to take this opportunity of Matlab simulating by connecting the load of the inverter through motor modules. By using the motor module as the load, we can observe the resolution of the motor to obtain an even clearer image of the performance of the inverter. Since the inverter of the electrical vehicle is in charge of to drive the motor of the EV. So that's all of my presentation. Thank you.